Alright, students, so for today's video, we are going to discuss the very last part for quadratic for our chapter 1. Okay, so this part we are talking about the simultaneous equation. And of course, after we learn the simultaneous equation, we are going to actually combine the concept with the nature of roots. Like when there's one line and one curve intersect with each other, okay, how many intersection points are there? All right, so generally we are going to link all this together lah. Okay, so simultaneous equation again, as what I told you before, or maybe as what you have it in your mind, you should learn it before, right? Okay, so for learning outcome 1.5, they want you to solve by substitution a pair of simultaneous equation. Okay, for our syllabus, usually they will put it as a linear and a quadratic equation. Usually, not 100%. All right, it might have some other cases also, but no matter how, as long as you want to get the intersection point, okay, I will tell students usually if you want to get the intersection point for the lines or the curve that intersect with each other, then generally you need to solve simultaneous equation. All right, so it is actually, how to say, this is the method, okay, to find the intersection point. Okay, so how are we going to get an intersection point between a straight line and also a quadratic curve? So first, you write the linear equation in terms of x or in terms of y, and then you substitute the equation into the quadratic equation and you solve it. All right, so this is what we do. Okay, so maybe you can have a try. For example, 14 and 15. Okay, so 14, maybe I can try it for you, and 15, you do it yourself, all right, because both are quite similar. All right, so I will try 14 for you first. Okay, so let's say I'm having one line here, like this is a straight line, and then this one is actually the curve, right? It is not a quadratic curve, all right? As what I said, they will not always ask you a line and a curve, but they might have some other thing else. So this is not a quadratic, and this is a curve. Okay, so when I'm having y equals to 11 minus 2x, I bring the 2x over. Okay, so I will usually rephrase it like this. So this one will be my equation number 1. And then my equation number 2 is this one, xy equals to 12. All right, so you can sub equation number 1 into equation number 2. All right, so your x is still the x, so y become 11 minus 2x, and then it is equals to 12. All right, so you try to expand everything. I don't know whether you can see or not. Generally, this is a quadratic equation. So if you rephrase it, this is what you get. Okay, so now you get a quadratic equation. You can try to solve it. So to solve it, you can either factorize it. You can use the formula of quadratic, up to you. So for me, I'm going to factorize it. From here, I get 2 value of x. Okay, and then to get the coordinate, you need y also. So you substitute 3 over 2 into either of this equation. Usually I will tell students you can substitute it into the linear equation, at least it is not so complicated. Alright, so you substitute 3 over 2 into the linear equation, and then you'll get an 8. And then for the second value of x, you will get a 3. Therefore, I will tell students, if they want you to find out the coordinates of intersection point, do you know what is the meaning of coordinates? That means it should be in a pair, okay, of x and y. Therefore, I will ask students to write out clearly that you should have first intersection point is this, and also the second intersection point is 4, 3. So I will want you to write your answer in the coordinate form. Okay, so this is what we have. All right, so I don't think that is hard. Okay, so for your information, what does this mean? It means that if let's say you're having a straight line and then you're having a curve, so the two values that you get is actually, okay, so this point itself is actually what? Is actually 3 over 2 and 8. I just simply draw lah, then this one is 4 over 3, something like that. Okay, the intersection point coordinate, or you can imagine that this is actually 3 over 2, and then when you're having the y-axis here, then this one should be the 8. I know that the graph is okay, but it is just for your extra information for you to understand. So when we talk about intersection point that they are going to calculate these two. Okay, all right. So in exam, no need to purposely draw the graph and see how the intersection point look like and where is it, no need. If you know how to apply the steps straight away, you can just straight away apply it. Okay, all right, no problem. So I want you to try example 15 yourself because example 15 is also very similar. Wait, so example 15. Okay, so answer for example 15 is -3, 11, and also another point is 2, 6. All right, so this is what you have for example 15. Please make sure you complete it and you can get the answer. All right, okay, so if no problem, let's continue to the next part. Okay, so under the extension of the simultaneous equation, generally, we can also try to figure out how many intersection points are there if I have a line intersect with a curve. Okay, to determine how many times a line intersect a parabola, you can actually substitute the equation of the line into the equation of parabola, and after that you use the discriminant. So this part actually combine simultaneous equation and also the discriminant cases together. Okay, so which means if you have a straight line intersect with a curve 2 times, okay, it is very similar to what we learned last time is when you're having a U-shape, a quadratic intersect, cut the x-axis at 2 points. They are having the same concept actually. All right, so we are using all this concept here to extend, okay, all the concept with some extra different style of question. Right, okay, so we can have a look here. Okay, so for first case, if your line and the curve intersect twice, generally for discriminant, you are using b squared minus 4ac greater than 0. That means it looks like you are having two roots, okay, two different roots. All right, two intersection points, which means also like two different roots. Therefore, when they ask you to solve some question related to this, you should use the discriminant b squared minus 4ac more than 0. Okay, so when your line and also the curve intersect at 1 point, then the discriminant b squared minus 4ac should be equals to 0. Intersect once is the keyword. Another keyword is the line is a tangent to the curve. Okay, so sometimes usually when students look at this, a line is a tangent to the curve, you should know that actually b squared, you can use the concept of b squared minus 4ac equals to 0. Because if you're having a line as shown and also a curve, then they intersect at 1 point only. So it is something very similar to the quadratic equation that cuts the x-axis at only 1 point. So for this case, is b squared minus 4ac equals to 0. All right, so I hope that you can link them together. Okay, they are actually having the same concept here. Okay, then after that, for part number C, if the line and the curve didn't intersect with each other, then you can say that b squared minus 4ac is smaller than 0. All right, so this is the extension from the previous knowledge that we learned before. Okay, let's see how are they going to ask us the question here. All right, so have a look for example 16. Okay, so the equation of a line is this. Okay, they want you to find the value of k when this line is a tangent to the curve for this quadratic equation. So you're having a straight line and also a quadratic equation, and the keyword is a tangent. All right, so when they want you to solve the question like this, first step, substitute the line equation into the curve equation first, just like you want to find out the intersection point. Okay, so you let y equals to k minus 2x. This is first equation, and your second equation is y equals to x squared minus 3x plus 4. Right, so you let 1 equals to 2, right? Okay, so from here, what do I have? K minus 2x equals to x squared minus 3x plus 4. And then I try to rephrase all these things into a quadratic equation. Okay, so maybe I try first, plus 4 minus k equals to 0. And then I might have x squared minus x plus 4 minus k equals to 0. Okay, so I hope that you can see that I actually get a quadratic equation here. But of course, I don't know the value of k, but I just know that k is a constant, which is a number. All right, and then this is a quadratic equation I get. And because in this question, they are talking about the line is a tangent to the curve, which means how many intersection points are there? Only. So when you substitute the line equation into the curve equation, it is like you want to find the intersection point already, right? So you know that there's only one intersection point from this keyword. Therefore, you should use the result b squared minus 4ac equals to 0 in the quadratic equation that you form when you solve the simultaneous equation just now. Okay, so what is your b? Negative 1, right? So negative 1 squared minus 4 a, c is the whole thing of 4 minus k, which is equals to 0. And then if you try to rephrase everything, you should be able to get the value of k, which is 15 over 4. All right, so this is how we solve this kind of question. Okay, it is like you assume that you want to find the intersection point, and after that you will start halfway one because you cannot solve it. All right, so when you cannot solve it, use the keyword given in the question, and then to continue. So like the keyword is a tangent. All right, so a tangent, I know that one intersection point, which means that I should use the result b squared minus 4ac equals to 0. Okay, so this is the important information that you need to know. Okay, all right, so if no problem, then maybe we can continue and have a look for example 17. Okay, so determine the set of value of k for which this line, okay, then you see the word intersect the curve. So you have a line and a curve. Okay, but for this keyword, they are talking about do not intersect. But I still need to focus on the word intersect first. So this one means that again, you can treat it like you want to solve the solve the simultaneous equation to the intersection point. Okay, so what we can do is like we can start. Let's say I'm having 2y, okay, equals to x plus k. So this is the first equation. And then the second equation is y equals to x squared minus 4x plus 7. So this is the second equation that I have. Okay, then I want to substitute, right? Either substitute 1 into 2, 2 into 1. Usually substitute linear into the curve. 1 into 2 will be easier. Okay, so you can substitute 1 into 2. Therefore, you are having x plus k divided by 2, which is the y, right? Y equal to x squared minus 4x plus 7. So if I continue from here, then what do I get is multiply the 2 up. I will have 2x squared minus 8x plus 14. And eventually I'm having 2x squared minus 9x plus 14 minus k equals to 0. Okay, so we double check again. You actually get a quadratic equation. Okay, but you cannot solve because there's a k here, right? So you know that this is a in front of x squared. Your b is negative 9, and this whole thing will be your c. Okay, so I go back to the keyword, to the question and look at the keyword again. Now, do not intersect. So do not intersect means that it is something like the quadratic don't have any solution. So which means b squared minus 4ac should be smaller than 0. Okay, and from here, if I continue, b squared is negative 9. I take the square minus 4ac. And this whole thing smaller than 0. Okay, so I try to expand everything. It is smaller than 0 also. You have 8k smaller than 31, and your k is smaller than 31 over 8. Okay, so this is what we have for our example 17. All right, so I hope that you get an idea how to do it, how to look at the keyword, and how to link it with the discriminant case. All right, okay. Example 18. Okay, so again, they give you a straight line and also a curve. They tell you intersect for how many points? 1 point, 2 points or no. So here they say two distinct points. Okay, two distinct points, it is something like you have two roots, okay, for your quadratic equation. So the same thing again, apply. So y equals to kx minus 4. First equation here. And then you're having y equals to x squared minus 2x. This is equation number 2. Again, you substitute 1 into 2. What do you get? So kx minus 4 equals to x squared minus 2x. And then you try to rephrase everything again. Okay, so here I will write it like this. I might have plus negative 2 negative kx plus 4 equals to 0. So again, when you look at the process here, you're still getting a quadratic equation, but you cannot solve y because you have the k inside. So I will treat this a equals to 1. This whole thing is actually your b, and the 4 here will be the c. Okay, so now I look at the keyword, two distinct points. That means you are having two intersection points. Okay, so two intersection points means that you are using b squared minus 4ac greater than 0. Okay, so what is your b squared now? Negative 2 negative k squared minus 4ac greater than 0. Okay, if you try to expand all these things, eventually you should get a quadratic inequality, which is k squared plus 4k minus 12 greater than 0. Okay, so if you look at this, now you are having the quadratic inequality in terms of k. Is this a quadratic inequality? Yes. Okay, you learned it before. So to solve a quadratic inequality, do you still remember what is the step? You need to factorize it first. All right, then you draw the number line. Okay, so for the bracket k minus 2, the line goes to the right hand side. For k plus 6, also go to the right hand side. So you have plus, plus, plus here, plus, negative, negative, and then negative, negative become plus. So to decide the final answer, I look at the equation that I have here, inequality, more than 0. So more than 0 means positive answer. So I only take the answer for this part and this part. Okay, so what does it mean? Your k, not x, because they are the quadratic equation is in terms of k, right? So when k is smaller than negative 6, and also the value of k which is more than 2, all right, then there will be two intersection points only when the value of k is smaller than 6 and also k is greater than 2. So you can have a look that for this example itself, they bring in another concept that you learned before. What is it? Quadratic inequality. Okay, so you can see that for all the concepts that we learned, now is in one chapter, all right? It is very common that for A-level style question, they will actually want you to use all the concepts from different chapters in one question. Because now we are in chapter 1 only, so you can see that the concepts are from different parts. Okay, so you need to really understand when after a particular concept, right, how are you going to combine it with all the other concepts to answer the question. Okay, so all this again, as what I said, you need to practice. That's why always for maths paper and stats paper, practice is very, 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 very important. All right, okay, so here we completed our chapter 1. So I think next video will of course start with our chapter 2. Chapter 2 is a long chapter, therefore you need to pay some attention in it. And then for chapter 2, right, we have quite a lot of new concept also that you never learned before. And a lot of students will feel that it is quite tough, okay, because you need to really know how to imagine. the graph and everything. Okay, the graph, how to do some analysis based on the graph and so on. So to some of the students, they will find that it's quite complicated because the pattern is not the same for every year, the question. All right, so you have to make sure that you really understand the concept, that only you can answer the question well. Okay, so we will do that in the next video. All right, okay.